Hello guys, Alan here. Welcome back to the shop. So, I'm about to head off in a weird direction. Probably one of the daftest projects I've tried to take on. But, to explain, a friend of mine had a Briggs Stratton lawnmower motor hanging around that he'd found beside the road, and he really felt that somebody should do something useful with it. So I thought, well, there's a challenge, and so I've got it, and I thought, well, what the hell can I do with it? Because I certainly don't need it as a lawnmower motor. And I thought, well, why don't I have a go at trying to make an air compressor out of it? Don't need an air compressor, so it doesn't matter if it doesn't work, but there's millions of these things lying around the place, so if it turns out that there is in fact an easy way to make them into air compressors, well, maybe somebody would want to do it. But this is right at the start of the thing, and this is quite a whimsical thing. Whether it will work out or not, I just don't know. But I've done a quick strip down of the thing, as you can see. Taken off everything that sort of doesn't really look like air compressor, I suppose you'd say. And the only trick in getting it disassembled to this state really is getting the flywheel fan thing off the top. If you want to do that, you'll have to make yourself a little puller. Nothing exciting, just a bar with 2 1/4-inch bolts at 1.5-inch centres and a centre forcing screw, and she'll be straight off. And this will probably be going back on anyway, because I'll reinstate the cowling for cooling if this thing actually works. So I probably didn't need to take it off at all, if truth be told. Anyway, the motor itself is in pretty good shape. I don't know whether I can easily turn it like this, but anyway, you can see it's moving up and down. So it's this particular Briggs & Stratton motor. It has a bore and stroke that gives it 174 cc swept volume, which works out, if you spin this thing at 1000 RPM, would give in theory 174 litres per minute, or about 6 cubic feet per minute. Of course, that's free air and not allowing for any leakage. But I've got it in mind to run it quite slowly, maybe only 1000. But as a further part to this project, if this thing actually does start working, I've sourced a 4 or 5 horsepower horizontal shaft Briggs & Stratton motor, a really old one. And so I might finish up with one Briggs & Stratton driving another. It's got novelty value, if no practical use. But if I was to go that way, that motor would easily drive this thing at 2000 RPM, which would in theory give you 12 CFM. But of course heat becomes an issue then, and I don't know about that. Anyway, I'm really not that interested in just exactly what it does achieve. It's more the fun of having a go at doing something that's fairly pointless but perhaps interesting. So where I'm going to start is with a cylinder head. I've decided there's no future in attempting to do anything with the standard valves. Just forget those, and I'll actually remove the camshaft. Whether I leave the valves in situ or not, I don't know yet, but anyway, they'll just not be part of the end solution. So I'm going to have to make a cylinder head up and use reed valves. So there's a fair bit of dicking around thinking about the best way to do that, and I won't be able to buy anything that'll do it, so I'll have to make my own cylinder head to sit on and house the reed valves. So that's where I'm going to start, because if I can't get that sorted, the rest of it's a waste of time. If that does work out, then at some point in the future I'll have to rejig the lubrication in the motor, because I want it to stand with the crankshaft horizontal. Well, that's enough of all that waffle. Let's go and have a look at the starting point for making this cylinder head. Okay, to cylinder head. Actually, I probably should have used the term valve plate rather than cylinder head. This is the head gasket from the compressor. And the way compressors typically work is there's a few variations on the theme, but typically they have reed valves, and you can see here that's the reed. And in this particular implementation, you get 2 plates which get separated by a shim or gasket like that, and then the other plate goes on top with another reed, which I won't try and put in. And it goes like that. So now you've got and they call that a sandwich plate for obvious reasons. So one of the reeds deals with letting air in, the other deals with letting air out. Now I picked this setup up from AliExpress. I think it was about $6, something like something ridiculous like that. And my initial idea was to use it just as design detail inspiration and to make a pair of these to that pattern. But then I thought, well, I don't know whether I actually need to do that. And so what I'm currently thinking is to make one plate which matches the cylinder head and put this pattern into it, and then use one of these plates on it together with the shim and the two reeds. So that's what I think I'm going to do for try one for this exercise, and I'm expecting to have to do some parts of this project more than once. It's just see what works and give it a go. Because one of the limitations is that the piston in the Briggs Stratton motor comes right up to the top of the bore, and it's a flat top piston, so there's no, some of these plates have bits and pieces hanging off the underside, you know, pegs that hold the reeds in place, things like that. Well, I can't do that because there's no room. So this concept means that that's what the piston sees, a flat surface. Right, so anyway, where does that take us? So now I need, in any case, and where I'm going to start is with a piece of cast iron, because that's the appropriate material for a valve plate. Even these cheapies are made out of that because of its stability, won't warp so much. So I need a piece of cast iron that I can make this out of, this size. So I had a couple of options. One is using this weight, and I can almost squeeze it out of that if I cut all the rest of the way and just cut that sort of piece out. But I'm still not sure whether I'd actually fully get it, so that's one option anyway, keep that in the back pocket. What I think I'm going to do in the first instance is try it differently. So obviously if I put that on there, I've got a hole in the middle. Well, that's alright. With this hole saw, I did a prototype, I can cut a disc out that size to fill that up. So what I'll do is machine both sides of this weight flat, and then there's enough room I can position this on here somehow like that. Exactly how doesn't matter. Let's say like that. And there's enough room for me to cut a disc out of it to use, and I'll silver solder that in the hole. So then I'll be able to have my piece. So that's my first go. That will be my first attempt at this. So it's over to the lathe, I think, to get rid of some of the material from this and head towards the flattened piece of stock that I need for the valve plate. So I'm going to get that into the chuck, but I think you can perhaps see that the jaws don't have a very good grip on it, and especially as this outer surface here is just rough ground. So I'm going to use the pipe centre as a bit of security to hold it in place. And actually this centre has been turned. It's got a consistent bore, which is good. So I'll put that in place just to make sure this can't fall out or dick around. Nip it up, and then clean some off the face here, and then I'll be able to turn it around in the chuck and get a proper grip on it without needing the pipe vise, the pipe centre. And let's see what that looks like. I'm only going at 275 here. Well, you can see there's quite a wobble with that. I did think about not using the pipe centre, but just sort of having a flat disc pressing against it to make sure it couldn't fall out. But really, I just wasn't very happy with the setup. Okay, had a change of mind. I realised that I might do better having it set up under the milling machine. Who knows? Anyway, at least I won't get any comments that you're taking your life in hand spinning these things up. So what I want to do first up is just basically rough it off, and so I'm starting off with a 1mm depth of cut, and we'll see how that goes. Alright, let's get it repositioned and see if we can get it levelled up a bit better. So I turned the piece over in the chuck and used some brass shim stock to level it up. Hopefully you can see that that's actually looking, well, that's remarkably accurate actually. And pretty good that way as well. So in terms of setup, what that has given me is the knowledge that we're going to be machining off here parallel to this face, which for our roughing is going to be good enough. Alright, and also I've got a better grip on it now because there's just more of it in the chuck. Now just touch off there, zero that with a quill DRO. Alright, well we're pretty much down at the same level inside and outside. I'm not sure whether it's a good idea trying to do the full width in one pass, because it's pushing here, I don't know, we'll give it a try, see what happens I suppose. I'm not sure whether I'm playing with fire though, we'll see. That's pretty much all the way there, so I think I might just come in with say a 0.1, see if I can get away with a 0.1 final pass. Alright, well that seems to have roughed that side off pretty well. So flip it over and do the other side. So to mount the disc in the 3-jaw chuck I need to machine the outer diameter. So knocked up a quick arbor and did a bit of thread cutting on the Hercus, so it's a 1-inch diameter and 14 TPI. Yeah, that'll be fine. Okay, next bit. So I've got the disc mounted on the arbor that I just made, so now I want to trim up the outside edge, or true up the outside edge here. I'm getting there. Do another. I'm only taking very light cuts of 0.2 on the radius each time because it's only being held by the friction here. I think we'll do one more cut and then call that it. Yeah, that's pretty good. I don't want those corners anyway. So I think we'll just lightly touch those corners with a file. Yeah, that's fine. Alright, on to the next bit. Okay, so I'm going to cut the slug out now, which I'll use to fill the hole up. And Perhaps keep in mind I'm making this up as I go along, so it's going to be perhaps a bit of a game of snakes and ladders. I'm bound to tread on a few snakes and get things in the wrong order or something. But anyway, I'm going to do this now. Let's have another look. I think a bit of depth monitoring is probably a good idea. So let's say, I'll say that's 0. And we're already 8.6 in, so we're quite a long way through. Seems pretty close. This is pretty close to 10 thick, so I don't have that much further to go. Alright. And there we are. I wonder if that's hot. Which I think it probably isn't, but let's see. No, actually it's quite cool, barely even warm. Okay, well that's our slug, and hopefully that's slightly oversized for the hole in the middle. Yep. Okay, so perhaps my process will be becoming a bit clearer now. I had this mounted on an arbor so that the outer diameter here would be concentric with the bore, because I knew that the slug that I was cutting out would be only a little bit bigger than the hole. So I don't have a lot of metal to remove here. But because of the way I've done it, when I put this back in the 3-jaw and clamp on this diameter, this should run fairly true. It won't be exactly true, but it should be pretty close. Close enough, I hope, that there's enough metal for me to bore out and make this the loose fit I need it to be for the silver soldering operation. So, back to the lathe. Okay, so we're set up in the 3-jaw. Perhaps you can see there is a bit of run out there, and I've got to take 0.28 off the diameter. So it's going to be a bit of a close run thing. But anyway, it's not like it has to be an interference fit or anything. It's just got to be a suitable fit for filling up with silver solder. Now let's see how we go. Well, the tape is not a good sign for getting a good result. Now we'll press on. But just to complicate things, this slug isn't actually very round. The diameter varies from 29.12 to 29.04. So we'll just keep taking little bits and hopefully it won't be too bad. Pretty close now. So now I'm wondering, for the purposes of silver soldering, whether it's better to press that in or make it a slightly, I think I'll make it a slightly looser fit. There's only a really small patch there that hasn't cleaned up now. Well, I think that's the sort of fit we want for silver soldering, so I can't take any more out. Alright, let's have to hope, and I'm pretty sure it's the case, that there's enough clean metal all around there that we'll get a good seal all the way around. And if it doesn't take just there, well, it shouldn't make any difference to what I'm trying to achieve. Alright, well, that's that part of the thing done. So I guess the next thing is actually to clean that flashing off and braze or silver solder this in. So I'd planned to silver solder the slug into the disc because I thought it would use less heat and therefore be less likely to distort the thing. So anyway, I hadn't tried to silver solder cast iron before, so I did a bit of online reading, and the idea was to heat the cast iron first to red heat to a significant degree, the idea being to flush out the free carbon, and then you cool it down, wire brush it and clean the surface, and then you should be good to go. So I thought I'd better try that process out first on a couple of bits of scrap cast iron, and so this is how it went. Okay, so after I did the business of heating them all up to bring the free carbon out and then wire brushed it off, did the same thing here, but as you can see, my attempts to get silver solder to stick to it before I tried something more adventurous was an abject failure. It just wouldn't flow. And I have no doubt that it's my incompetence that was the problem, because I'm sure that I didn't have the flame right or the temperature right or something. But that was a pretty simple test and I failed it, so I'm not going to try to do that with my the piece that I'm making for the mower. So now I'm going to try a different approach. I think I'll just try brazing and see how that works out. Well, that brazing seems to have taken pretty well all the way around, so that's encouraging. We'll let that cool off and have a closer look. Okay, so it's cooled down. I've scrubbed it with hot water to get rid of most of the flux, and that's actually gone on pretty well. Quite happy with that. I don't know how well it's going to work with the capillary action though, which is what I was hoping for using the silver solder. But right now I'm thinking it's my only real chance. So I think it's going to be suck it and see and hope for the best. Okay, so now I've decided that I'm going to do brazing. I was checking the clearances that you need for capillary action with brazing. It's a bit more than you need for silver soldering. A couple of thou seems to be the go, a couple of thousandths of an inch. So I've just emeryed out the hole slightly to make this that sort of a fit. Perhaps you can see. Just sort of drops in, doesn't go all the way through, just sort of, there's a slight taper on it. Anyway, I reckon that's easily a couple of 1 to 2 thou sort of fit. Oops. So that's what we're going to go with. And I found a couple of smaller brazing rods too, which I'm definitely happy with. So let's get some of this goop on. Alright. I don't have much experience of this, in fact virtually no experience, so I don't really know how much preheating to do. I don't know, just get what seems like a lot and need a little bit more and hope for the best, I guess. I think I need a bigger tip. Well, it's not looking too promising at this stage, but I thought I'd turn it over and have a look at the other side and perhaps see if I could improve things from that side. I think I have to accept I haven't got enough flux on. I have to wait for it to cool down, I guess, and start again. Okay, so next day, and this has cooled down. I've given it a bit of a wire brush and a bit of a clean up. So let's have a closer look at what we've got here. So I think you can see that quite a bit of the, well, a useful amount of brazing did seem to stick on there, but it was very patchy, very ugly looking sort of appearance. And the other side was a lot worse. So what to do? The slug is actually sticking out a little bit, about 0.5 millimetre or something past the back of the plate here, so that's unfortunate. So one of my options that I've been thinking about is to use a really big tip. I've got one which I think people call a rosebud, which might be capable of bringing all of this up to brazing temperature at the same time, so then I could push this back down. I don't know how much of that's wishful thinking, but I might give that a try. But failing that, I suppose I can put the thing back in the lathe and just face it off and clean that off and try to improve on what's there without changing anything else. And actually thinking about it, that might be the best option, because you can see here there's still a good 0.5 millimetre to take off to get down to a completely flat surface, and that'd bring me down to the level there anyway. So perhaps that's the best option rather than stuffing about trying to do the whole thing at once. So I think maybe the best option is put it in the lathe, clean this face up and get ready to try to improve the brazing on this face, and same on that. Just see whether we can do things a little bit better, because I think there's enough brazing that this isn't going to fall out, but of course it's got to be pressure resistant as well, because I think the cylinder pressure could easily hit 150 psi, maybe higher. So it needs to be pretty good seal. Anyway, so I think that's what we do. Put it in the lathe, clean it up, and then have a go at improving what we've got. So I'm sorry about the rain, but we have to press on. So I've redone the back side, or sorry, the side that was the worst side, and I think that's going to clean up pretty darn well. The other side, which was the better of the two, actually after it was cleaned up it didn't look too bad at all. There were a couple of little spots where it didn't take, but I think that it only has to be sealed. It doesn't matter if this side isn't perfect, so I'm thinking I'm going to leave well alone. Just clean this up and clean this side up and call it done. Okay, so I've given it a quick clean up, enough I think to show that I've got it, and I'll do the rest because I've got to change the 3 jaw setup to different jaws. I think that's going to be fine, so we'll press on. Okay, so I want to machine this face off, and so I've got my standoffs mounted on the chuck, and I just need to skim them all to make sure they're all at exactly exactly the same height. But that will then hold this in the chuck with enough sticking out that I can face it off. Make sure everything misses all the way around and then all the way over here. It's a close run thing, but I will just get away with it. Okay. Yeah, looks like that's got it well enough. Right. I've got to get the hole halfway between a support post and the jaw. Just pull back a little bit so I've got a bit of hammer room. Tapping room, perhaps I should say. Sounds nice and solid, doesn't it? It's not going anywhere. I use this cutter to trim the aluminium pieces because it's really sharp, but I can't use it to cut in. It's not a it's a left-hand cutter, not a right-hand cutter. Still got to make sure everything misses. Yes, that should be all right. Make that all the way to the middle, won't we? So let's see how we get on with that. Well, that sort of seems to be going all right. So I'll take a slightly bigger cut this time. Oh, and find a hole. Oh, it doesn't matter there because that would be a bit that's cut off. That's right. That's why one of the reasons I put this hole is there, because I saw these imperfections. Okay, well, there we go. Oh, that's got that side cleaned up. Flipping over, and I only have to do a very light skim on the other side, I think. Okay, see if we can get it in one pass. You never know your luck. Well, there we go, managed to get that side in one pass. So, time to take stock of where we're at. Okay, well I think I've got a little bit of a milestone here. Obviously I've completed the blank, and now I've got a piece of cast iron which is flat and parallel on both sides, big enough to make my valve plate out of. I was quite pleased with how well it turned out. If you look really closely, perhaps you'll be able to see the join line, which is just the edge of the brazing, I guess, a little sort of a silvery sort of look. So that actually worked out quite well in the end, although if you've watched along, it wasn't without its trials and tribulations. There were certainly some learning outcomes, and I've got more experience now with brazing cast iron. But anyway, some other projects have backed up a little bit while I've been doing this, and so I've got to put it to one side for a little bit. But when I resume, which won't be very long, I'll be laying this out, drilling, cutting and producing the plate which will bolt onto the cylinder block. So, hope you've enjoyed this episode, and perhaps join me on the next one to see some more progress with this. Cheers.